We're going to demonstrate how to measure a cylinder of an engine, and when we measure it, we're measuring it for three things: for its bore size, for its taper, so whether it's wider at the bottom or the top, and for its out of round, whether it is perfectly round or whether it's oval shaped. And we're going to do that with a dial bore gauge. Of course, a dial bore gauge can't measure anything by itself, and so we're going to use a micrometer to set this at 0. So we found the specification right here. The standard diameter for the cylinder bore is 3.7795 inches. It gives us a range, but we're going to set it at the lower number. So I'm going to set the micrometer at 3.7795. We've got it set already and locked. Then we'll take this to a vise. I put a rag in the vise and I set this inside of here just lightly, and then I very lightly tighten that down. Don't tighten it very much or you'll distort this. Then we find the appropriate attachments for this dial bore gauge. We've already done that. And we put it in here in between the micrometer. And then I'm going to rock this back and forth, and when we see that dial, or that needle, change directions. And this is probably the trickiest part of this whole operation, is getting this set to 0. It's close already. I'm holding the back and rocking it. You'll notice that needle's turning around. Let's see, where's it at? It's really close to 0. Let's turn just a little bit more. Okay, I think we're there. The needle's turning around right at the 0. So I'll carefully pull it out. And we'll come over here to the engine block. We'll start with cylinder number 1. And what I'm going to do is make myself a chart. So we're going to measure each cylinder in 6 different places. 3 at the top and 3 at the bottom. So I'll make a chart like this. Pen to work. Cylinder number 1, top, bottom. And then I'm going to say position 1, position 2, and position 3. Now I'm going to take my measurements. So I'm always going to use position 1 as it's perpendicular to the engine block. This is the direction that the piston would rock back and forth, and so this is where the most wear would occur if there is wear in the cylinder. So I'll call this position 1, and I'll go down just below the ring ridge here. So just down about 1/2 inch or 3/4 inch into the cylinder, and I'm going to rock this and watch that needle go around and around, and it stops right there. And on this dial, each little tick mark is a 1/10,000th of an inch, and then the large numbers represent 1,000th. So this is actually just slightly more than 2/1000ths of an inch larger than the specification we set the micrometer to. In fact, to be specific, it's 2.4 thousandths of an inch. So I'd come here to position 1, I'd write 0.0024. Now position 2 I'm going to do here, and then position 3 like this, so that we're just slicing the cylinder into equal slices here. So position 2, there it's about exactly 1,000th of an inch. And position 3 will be like this. And right there it changes direction, so it looks like it's right on the 1,000th of an inch mark again. So what these represent is how much larger than the specification the cylinder is here. So I'll do the same thing at the bottom of the cylinder. Position 1 at the bottom. Looks like it's about 18 10,000ths or 1.8 thousandths Try it one more time. Or 19, depending on where I move it to, there's a little bit of variation. So we'll say 18. Okay, now once we have these numbers, here's where we can calculate our taper and out of round. So if I look at position 1, top and the bottom, I'm going to come over here and I'm going to say, what was the difference between those two numbers? And it's 0.0006, right? 6 ten-thousandths of an inch. And I'll do that all the way through here. In this case, there was 0.0001, and here it's 0.0008. The largest of these three numbers is this one, so I'm going to call that my taper. The most taper that I found here was 8 ten-thousandths of an inch difference between the top and the bottom of the cylinder. Now to find my out of round, I'm going to compare these to each other. What's the difference between the largest and the smallest number? It looks like it's 0.0014. And here, 0.0007. The difference between the largest and the smallest measurements we took. The larger of these two numbers, obviously, is this one. So that's my out of round. Now, you'll say, what was your exact bore measurement? So I'll come back to my specification here. 3.7795 is my specification, and I find the largest number that I measured, which was this one, and I add 0.0024 to that. So my bore measurement, the largest measurement in that bore was 3.7819 inches. And now I've taken all of the measurements and I can compare those against my specifications and find out if I need to do anything with my cylinder, if I need to have it bored out or if it's okay to use. As long as everything falls within that specification. And I've also got specifications for out of round and for taper. As long as these numbers fall within those specifications, I can reuse the cylinders like they are. I can just hone them and reuse them. Otherwise, they have to be bored out. So one thing to be aware of is as you take this measurement, but if it's to the right of the zero, it's actually smaller than the specification. So in this case, it's to the right of the zero. It's smaller than the specification that we set the micrometer to. That doesn't happen often. Cylinders don't get smaller, but for some reason, either our specification is wrong or the cylinder is distorted, but this is showing us it's 3 thousandths smaller. If, on the other hand, it stopped over here on the left of the zero, somewhere on this side, that tells us that it's larger than the specification, and that's most typical.